All right, these are the solutions for assignment number 3. Question 1 reads, find the shortest distance from the point to the plane. Okay, so let me just get my, okay, there we go. Let's rewrite the general formula from the distance from a point to a plane. So recall that the formula for the distance from some point, or from a point rather, let's call that point x0, y0, z0, to the plane of the form ax plus by plus cz plus d is, so we use d for distance, it is the absolute value of a x0 plus by0 plus c z0 plus d all over the norm a squared plus c squared. In our case, with regards to our question, we have that a is equal to 3, b is equal to -2, c is equal to 1, and we have that d is equal to 1 as well. And our point x0, y0, z0 is the point 1, 2, 3. So all that we need to know, all that we need to do now is take these numbers, insert it into our formula, and we'll get the distance. So you have 3, just like side booking if you want. We have 3, that's a, by 1 minus 2 plus 1 by 3 plus 1, because d is 1. That will give me 3 minus 4 plus 3 plus 1. That is equal to 3. So our numerator is the number 1. Now for the denominator, we have a squared plus b squared plus c squared. So 3 squared plus -2 squared plus 1 squared. That gives me 9 plus 4 plus 1, which is 14. So put that into our formula now for distance d. We get the absolute value of 3 all over root 14, which is equal to 3 all over root 14. Okay, so that is our distance here. If you want, it's optional. You could rationalize and multiply numerator and denominator, top and bottom, by root 14, right? But it's not necessary here. So moving on to part B now, it says find the shortest distance from a point to a line. Okay, and our point here is 1, 0, -2, and we have our line here in symmetric form. So B asked me for the distance from this point 1, 0, -2 to this line that is in symmetric form. So what I'm going to do now, I'm going to convert it into parametric form, so that we can use this point with the relevant equation for distance and find. So in order to do so, let's take the symmetric equation that we are given, which is x minus 2 all over 1 is equal to y plus 1 all over 2, which is equal to z 1, 3. I'm going to introduce the parameter t. Okay, so it doesn't need to be t. It could be anything that you want. It could be lambda, it could be mu, it could be sigma, it doesn't matter. And let's rewrite. So then our numerator x minus 2 will be equal to t, y plus 1 will be equal to 2t, and z will be equal to 3t. Make x the subject of the formula, y the subject of the formula, and z. So you'll get x is equal to 2 plus t, y is equal to negative 1 plus 2t, z will be equal to 3t. It's already 3t. So the point, 1 point or a point, therefore, 1 point on the line is the point that we are given. Actually, point on the line A is a point by taking the coefficients here. So we have 2, we have negative 1, and well, we have 0 here. We have no point here. So we have negative 2, sorry, positive 2, negative 1, and 0. That is if t is equal to 0. This is by setting t equal to 0. And the direction vector now, and the direction vector is, let's just use d for direction vector, is 1, 2, and 3. The direction vector is 1, 2, 3. So using our fixed point now, using our fixed point we're given in the question, I'm going to call that point P0. So this particular line, we'll have to use the distance formula, the standard formula from the distance for the distance d from a point P0 to a line through a point which we called A over here. Okay, and direction vector d is this. And that formula is P0, the initial point, minus A, the norm, multiplied by the cross of D all over norm. The D is the direction vector, and this fancy D here, I'll just put a little tail for it so it'll tell the difference, is the distance. So the first thing that I need is P0 minus A. So I need the direction vector AP0. So we have A. So let's write number 1. Find vector from A to 0. So A is equal to 2, negative 1, 0. P0 is equal to 1, 0, negative 2. So A P0 is equal to P0 minus A, which will give me 1 minus 2, comma 0 minus negative 1, comma negative 2 minus, which is equal to negative 1, 1, and negative 2. Now I need to find the cross product here. Okay. So number 2. Find the cross product A 0 cross P. Just verifying that I did in fact did the correct distance. Sorry, the correct point 1 0 negative 2. Yes. So I have I have J, I have K, I have -1, I have 1, -2, 1, 2, 3. So let's expand along the top row. So I'll get this is equal to I'll have -1 multiplied by, so I'll have 3 by 1, which is 3, minus -4, because that's 2 by -2. So I'll get my first term here as 7. The next term will be -3 plus 2, which is -1. Negative of -1, so I'll get +1. And the last term will be -2 minus 1, which is -3. So I have -3. So now I'm going to take this here. I'm going to find, let's go back up. Don't forget, I need to find the norm of it. So I need to find the square root of the squares of the terms. So norm of AP0 plus P equal to square root of 7 squared plus 1 squared plus -3 squared. This is equal to 49 plus 1 plus 9, which gives me root 9. So that's my numerator. And then the denominator asks for the magnitude of the direction vector. We want the magnitude as well of P. And D was 1, 2, 3. So we have 1 squared plus 2 squared plus 3 squared, which is equal to 1 plus 4 plus 9, which is equal to 40. So finally, take this information and put it in the formula for the distance. So remember, I put a little tail for it. Numerator is root 59, and the denominator is root 40. So therefore, the shortest distance from 1, 0, -2 to that line which we had is root 59 upon root 14. And if you want, you have the option of taking the square root and bring it all under common square root, but this is sufficient. Okay, so that is part B. So moving on to part C now, we have to find the equation of a plane such that any point on this plane is equidistant from the points 1, 0, 1 and 3, 4, 3. Okay, so if they are equal distances, as the question said, then maybe we can use our midpoint formula. Okay, so if these 2 points, let's call them 2 points, maybe P and Q, and they are equal distances, then we need to find the midpoint of PQ. Okay, so let's write that. We can see the set of points equidistant from P and Q is the perpendicular bisector plane of segment PQ. So therefore, the midpoint of PQ is to take the 2 points 101 and 343. So we are the midpoints. We have 1, 0, we have 1, then we have 3, have 4, and then we have 3. All of them divided by 2. All of them are points, which will give me 2, 2, 2. And we also need to get a normal vector to the plane. So a normal to the plane PQ is Q minus P, which will give me 2, 4, 2. Is parallel to 1, 2. So finally, we have that plus the plane passing through our midpoint, which is 2, 2, 2, with normal 1, 2, 1, satisfies a into x minus x0 plus b into y minus y0 plus c into z minus z0. So we have 1 into x minus 2 plus 2 into y minus 2 plus 1 into z minus is equal to 0. Simplify this, you get x minus 2 plus 2y minus 4 plus z minus 2 is equal to 0. So we have plus 2y plus z minus 8, 0. Okay, so this is one possible way that you can do it. Another way that you can do the same thing is that you can take a point, a random point, I shouldn't say random, but a point that's lying on the same plane that we want, and take the 2 points that we are given in the question, P and Q, and show that they are equal. Because remember, the question said that they are equidistant, right? So alternatively, what we can do here is that we can say alternatively, or we could write instead is that we can let P be equal to what we are given and Q equal to another point, and then take another point, let's say a point x is x, y, z lying on the required plane and must satisfy following. That is, x minus p is equal to x minus q. And this only works because we were given that they are equidistant. So we can take the 2 points, insert them into this equation here, solve them, and we should get the same answer. That is, we should have, so I'm going to use, so p is 1, 0, 1. So it's x minus 1 squared plus y minus 0 squared plus z minus 1 squared is equal to x minus 343. So 3 squared plus y minus 4 squared plus z minus 3 squared. Okay, we should expand these, simplify, and let's see if we get the same equation, right? So the left hand side I'll do first. The left hand side, so I'll get x minus 1 all squared, so I'll get squared minus 2x plus 1 plus y squared plus z squared minus 2z plus 1. Let's just simplify this. So I get x squared plus y squared plus z squared minus 2x minus 2z plus 2. So that's the left hand side. Let's do the right hand side now. So I'll get x squared minus 6x plus 9 plus y squared minus 8y plus 6 plus z squared minus 6z plus 9. Simplify this now. Let's see. Squared plus y squared plus z squared minus 6x minus 8y minus z plus 69, 9, that's 34. Set them equal to each other now. So we can set 1 and 2 equal to each other, and we'll get z plus y, z plus z, x, z, 2 is equal to squared, y squared, z squared minus x. From both sides, we see that x squared plus y squared plus z squared will cancel out each other on both sides, which just leaves me with all the terms in x. I have y terms on the right hand side only, and z terms as well. We have negative 2x minus 2z plus 2 minus everything else that remains, which is negative 6x minus 8y minus 6z plus 34 equal to 0. I just take the terms on the right hand side and bring them on the left hand side. Okay, so negative 2 minus negative 6, so we have 4x plus y 4z minus 32 is equal to 0. And then every term here is divisible by 4. So I'll get x plus 2y plus z minus 8 is equal to, which is exactly the same thing that we had before. Okay, so both answers are the same. Doesn't matter which method that you use. All right, so now we're going to move on to question number 2, which says that let L1 and L2 be the lines in R3 given here. Determine whether the lines are parallel, intersecting, or skew. So question 2 gives us two lines. Are they parallel? Let's check and see. The first direction vector, call it D1, from the first line is 1, 0, negative. Second direction vector is 0, 1, 1. Are these scalar multiples of each other? No, they are not. Right? So we can say that since D1 is not a scalar multiple of D2, and the lines are not. Now we have to determine if they are intersecting. Okay, so I'm going to take the two lines here and I'm going to equate them. So the first line gives me 0 plus t is equal to 1 plus 0 lambda. Second one gives me 0 is equal to 0 plus lambda. The last one says 1 minus t is equal to 1 minus lambda. Okay, so now let's solve these here. So from the second equation, I can immediately see that lambda is equal to 0. So I'm going to take lambda is equal to 0. I'm going to put it inside equation number 3. So I'm going to get 1 minus t is equal to 1 minus 0. So therefore, 1 minus t is equal, just draw a line here so we can show. So 1 minus t is equal to 1. Implies t is equal to 0. So put t is equal to 0 inside equation number 1, and lambda equal to 0. We'll get 0 plus 0 is equal to 1 plus 0, and 0 is equal to 1, which is impossible. So therefore, so this is a contradiction here, right? So this is a contradiction. Therefore, the lines do not intersect. Hence, they are in fact skewed. They are skewed. That is non-parallel and non-intersecting. So part B now asks me to find the shortest distance between the lines. In fact, here it'll be the shortest distance between the skew lines, because that is what we just found out. Okay, so we have to choose some fixed points here, and then use our distance formula and get whatever the shortest distance is here. So let's do that. Part B here. So let's choose points. Let's call the first one P1. Okay, that's from line 1. So it'll be 0, 0, 1 inside line 1. Another point P2 in line 2. So let's say 1, 0, 1 inside line 2. Okay, taking these here. So now I have 2 points here. So find R, which is my vector. So R will be equal to P2 minus P1. So if I subtract these, I will get P2 minus P1. I'll get 1 minus something like 1, 0, 1 minus 1 is 0. Now put this into the standard formula for the distance between two skew lines. Remember that distance E between two skew lines is the R dot E1 cross E2, the absolute value all over the norm E1 cross. So I need to find D1 cross D1 cross D2. I'll get I A K. I'll have 1, 0, negative 1, 0, 1, negative 1. So I'll get 1, 1, 1. Also, I need the norm. Is 1 squared plus 1 squared plus 1 squared, which is just root 3. So put this inside my distance formula now, d. So I'll get the absolute value 1 all over root 3, which is just 1 upon root 3. Okay? And that is the shortest distance. Of course, you could multiply numerator and denominator by root 3 if you want, but that's not necessary here. Okay, this is good enough for the shortest distance. Now we're moving on to question number 3. It gives us two planes and they ask us to determine if the two planes are parallel or not. Okay, and then we are asked to find a point and then the line of intersection if it exists. Okay, so let's see how we're going to do that. This is question number 3. So we are given the two planes. So let's find a normal. Let's extract the normal from each plane, right? So the first one gives me -2, 3, 7, and the second normal is 1, 2, 3. Sorry, -3. Are they parallel? No, they are not, because there is no k of n1 that is equal to n2. So let's write that they are not parallel, since it does not exist k that's real, or real scalar k, that satisfies k n1 is equal to n. So the normals are not parallel, which means that the planes are not parallel as well. So that takes care of part A. Okay, so now we're going to move on to part B, which says find a point that lies on both of these planes. So in order to do that now, I need to form some simultaneous equations and solve them. Okay. So we are given that, I'm just rewriting the planes, right? -2x plus 3y plus 7z plus 2 is equal to 0. Let's call this equation number 1. And we are also given that x plus 2y minus 3z plus 5 is equal to 0. That's my second equation. Yes, it's a nice, so you have a couple of things that you can do here. You can either set z equal to 0, eliminate z, and then solve for x and y, and then you'll get a point where z is equal to 0. Or, which is what most students will do, which is fine. Okay, I'm just going to do it a little bit differently to just show you that you can do something else, and that is set z equal to a parameter, right? So I'm going to let z be equal to t, be a free parameter. So I'm going to substitute z equal to t and then solve each of these equations. So the first one becomes -2x plus 3y plus 7t plus 2 equal to 0. The second one becomes x plus 2y minus 3t plus 5 equal to 0. So for each of these, let's take this one here. Let's throw everything that has t on it and my constants on the right hand side. So I have an equation only in x and y on one side. So I have -2x plus 3y is equal to -7t plus 2. Sorry, minus 2. minus 2. Okay, so let's call this equation 3. And then let's also do the same thing for the next equation. Okay, that is, let's say x plus 2y is equal to 3t minus 5. And let's call this equation 4. So, you know, we could maybe take equation 4 and multiply by 2 and then add the two equations and eliminate. That's okay. But I already have x in equation 4. So maybe it's a good idea, just for the sake of time, to take equation 4 and make x the subject of the formula and then substitute it back into equation 3. Okay? So from 4, I would have that x is equal to 3t minus 5 minus 2y. So that's equation number 5. Okay, so I'm going to take 5 now, and I'm going to put it inside equation number 3. So I'm going to get negative 2. I'm going to get negative 2 into 3t minus 5 minus 2y plus 3y is equal to negative 7t minus 2. Okay, so let's simplify this now. So we get negative 6t plus 10 plus 4y plus 3y is equal to negative 7t minus 2. Negative 6t plus 10, 137 plus 7y is equal to negative 7t minus 2. I'm going to take the negative 6t and the negative 7t. That'll just give me t plus 7y. 10 and 2 is 12, equal to 0. So 7y now is equal to negative t minus 12, which means y is equal to negative into t plus 12. I just separate the signs, right? Upon 7. So now we have y. Now substitute y is equal to negative into t plus 12 upon 7, right, to get x. So now x, so we get x is going to be equal to 3t minus 5 minus 2 into negative t plus 12 upon 7. So I'll get this is equal to 3t minus 5. I'll get plus 2, because minus minus will come inside, plus 2 into t plus 12 all over 7. So let's find a common denominator of 7. Add them like normal fractions. You'll get 21t minus 35 minus 2t plus 24 all over 7. Let's simplify now. I'll get 21 and 2, that's 23, t minus 11 all over 7. And this now is x. So we have x is equal to this. We have y is equal to this. And well, z is just equal to t. Okay? So now I need to find a... Remember the question asked. Let's go back to the question. A point that lies on both of them. Okay? So we find x and we find y. So now I have to choose a convenient value for t in order to get a point. Right? Now, if you had started with z equal to 0, your point will be different, right? But that's fine as well. So by looking at, let's go back to y. I realize that if I use t is equal to negative 12, or 12 rather, then I'll get 0 for y, because negative 12 plus 12 will give me 0. And then, yeah, that's fine. So I'm going to choose. Of course, I could have done the same thing for x as well. Choose a convenient value and 0 the value of x, right? The convenient and you'll get p is equal to, so putting 12 over here, negative 12, you'll get negative 41, get 0, and of course this is off. Of course, again, as I said, if you use z equal to 0 from the beginning, this will be different for you, okay, which is fine. So moving on back to parts, so moving on to part C rather, now we want to find the line, we want to find the line of intersection. So my line here may be different from yours, right? Because remember, your z was probably something else. Maybe you let z equal to 1, maybe you let y equal to 0 or something like that. So there isn't any one way that I would say I have to do it like this, right? It depends on which way that you are comfortable with. So see, since z was my parameter, okay, so with z being equal to t for me, right, as parameter, the reason for introducing parameters like this is to get you familiar and comfortable with solving equations of this nature when we were doing matrices or when we had reached matrices. Okay, so it wouldn't be anything foreign to you and you would have seen it before. With z equal to t as a parameter and the expressions we have for x and y, then my intersection, then, well, the intersection rather, set is of x, y, z. So I have, so from my x, I have 23t minus 11.7. So I have 23 upon 23t upon 7 minus my y, which is minus 11 on 7, comma, negative t upon 7 minus 12 upon 7, and z is equal to t. T is, so we could take this and we could write it in vector form to make it look a little better. So r is equal to xyz, so negative 11 upon 7, negative 12 upon 7, 0 plus t, 23 upon 7, negative 1 upon 7, and 1. So if you had chosen z equal to 0 or something, you may have an answer that looks similar to this, except with the denominators being 7. So you would have maybe multiplied throughout by 7, which is fine as well. Right? So you would have gotten 23 negative 1, 7. Okay, which is the same, right? It is just this is just the fractional version of it. Okay. So either solution is acceptable. So finally, we are at question number 4, the last question. It gives me two planes here, and it asks, are the planes intersecting or parallel? If they are parallel, we can look at the direction vectors and we could immediately see it's not parallel, right? If they are parallel, which they are not, find the distance between them. So we don't need to do that. Okay? Otherwise, find their line of intersection. Okay, so we will need to do that. And the angle between them. Okay. So let's write something to say that they are not parallel because we can clearly see that. And then let's find this line of intersection that they're talking about. Okay. So we have pi 1, so a point, let's say p1. Let's just extract our points immediately, right? We have 1 and 1. And we have a normal vector 0, 4, 5. Pi 2, we have 1, 4, 0. And we have n2, which is 1, 2, 3. So they are not parallel. Not parallel. Well, okay, they are not parallel. Oh, let's write a little statement. Since no scalar a satisfies a and 1 is equal to 2. So the normals are not parallel, hence the planes are intersecting. So I need to find, before I even, let's get back to the question. Okay. So I need to find point on both planes. Now, I know at some point in time, because they're asking for the line of intersection, I need to get the direction vector. So because I already have the two normals here, I'm just going to go one time and just cross them, right? Just to find the direction vector. Because I know I'll need it, right? For the line. So it's 0, 4, 5, cross 1, 2, 3. That will give me 0, that'll give me 2. That'll give me 5. And that'll give me -4. So that's what the direction vector for the line of intersection is. Okay, this is my direction vector. Now I need to find a point on both planes, which means that take the two planes that we have here, set up two simultaneous equations like we did in the previous question, and then solve them. Okay, let's see what we get. So I have 4y plus 5 into, let's look back at this, 4y okay, plus 5 into z minus 1 equal to 0. Second one is x minus 1 plus 2 y minus 4. 3z is equal to 0. So from the first one, I'm seeing that I have, okay, so let's simplify. I have 1, 2. So from the first one, I have 4y plus 5z minus 5 is equal to 0. So that means that 4y plus 5z is equal to 5. Let's call this maybe equation 3. Okay, so I'm going to leave all the unknowns on one side and maybe take all the constants and throw them on the next side. For the second equation, I'm going to do the same thing. So I have x minus 1 plus 2y minus 8 plus 3z is equal to 0. So therefore, x plus 2y, -1 minus 8, that's -9. And then throw that on the next side, gives me +9. So this is equation number 4. So let's do something different from the last time. I'm going to let z be equal to a convenient value of 1. Okay, so let z be equal to 1 and put that in equation into equation number 3. So I have 4y. I only put it in equation number 3 because we have less terms, right? Equation number 4 has x, y, and z. But equation number 3 only has y and z. So we have 4y plus 5 is equal to 5. So therefore 4y is equal to 0. There's 5 on the next side. So that means y is equal to 0. So I have that y here is equal to 0. Take y equal to 0 and z is equal to 0 as well, and put them inside equation number 4. So you'll get x plus 2 into y, 0, plus 3 into z is equal to 9. So you'll just get x plus 3 is equal to 9, which means that x is equal to 6. So now we have x as well. So x is equal to 6, y is equal to 0, and z is equal to 1. So this is a convenient point here. We could say one possible, convenient, common point is, you could call it point something. Let's call it A. We have 6, 0, 1. So therefore, my line of intersection, call it here my vector equation. So I'll have 601 plus, I know you guys like lambda, so use lambda into my direction vector, which I found all the way at the beginning. 2, 4, 2, 5, negative 4. 2, 5, negative 4. Of course, lambda is real. So remember that the question asks for two things, right? We are dealing with the intersecting part because they are not parallel. Okay, so they said that find their line of intersection. We just did that, and the angle between them, So we need to use the formula, the cos inverse, the cos theta is equal to, you multiply the two normals and you divide by the norm of the two normals multiplied by each other. So I want to find the angle between planes, and that is angle theta between planes is equal to the angle between their normals. Okay, I'll just write in a nice little statement to say that what we're going to do. So cos theta is n1 dot n2 all over the norm of n1 by the norm of n2. So we have, I'll write it here. So I have 0 by 1 plus 4 by 2 plus 5 by 3 all over. First one is 0 squared plus 4 squared plus 5 squared by 1 squared plus 2 squared plus 3 squared. So the numerator gives me 8, 15, and 1. That's 23. And the denominator gives me, the first one is 16, 25. That's 41. And the second one gives me 9, 4, and 1, which is 14. So that gives me 23 all over 41 by 14. That is square root of 574. So now I want theta, which is cos inverse of 23 all over 574, which is however how much that you get in your calculator in degrees or radians. So I'll leave this part up to you guys, because as I gave in the instructions, I said that whichever answer is acceptable either in degrees or radians, but just for consistency, if there were more questions on the assignment, give all your answers in degrees or give all of them in radians as well. So this brings us to the end of assignment number 3.